Hello everyone, welcome back to our channel. We were discussing about complex numbers and quadratic equations from class 11th Maths NCERT. In the last class we discussed I is iota whose value is equals to minus 1, root of minus 1. I square will be equals to minus 1. Say you have a negative number minus 4. This minus 4 can be represented as minus 1 into 4, which is equals to 4i square, or 2i whole square. Minus 4 is equals to 2i whole square. If I take square root on both sides, we'll get minus 4 is equals to plus minus 2i. That means minus 4 or root of minus 4 has two values. One, 2i, and second, minus 2i. Similarly, if you have two values, say 2i and minus 2i, and if you take square of these two values, you'll get 4i square, and minus 2 square is also plus 4, so 4i square. This is equals to minus 4. This is equals to minus 4. This is just an explanation for the concepts that we've studied. We can generalize this as root of minus a is equals to plus minus root a into I. Now, let's say you have two values, root a and root b. Root a and root b. And now you're multiplying root a and root b. If a and b are real numbers, then this is the result that we know of. That means you can directly take the root of multiplication of a and b. Now this value is not, this equation is not valid for all values of a and b. Let's consider positive values of a and b. When a is greater than 0 and b is greater than 0. If both values are positive, we'll consider examples and we'll try to understand whether the equation is valid through examples. So let a is be a positive value 4 and b be another positive value 2. So your LHS is equals to root a into root b. This is equals to root 4 into root 2. This is equals to 2 root 2. Your RHS is equals to root of 4 into 2, which is equals to root 8. This can be written as 2 root. So when both a and b are positive, this equation, our equation 1, is valid. When both a and b are positive. And what happens if either one of them is negative? Let's consider two scenarios. One where a is positive and b is negative, and another where b is positive and a is negative. For a to be positive, a has to be greater than 0 and b has to be less than 0 for b to be negative. Second scenario is a is negative, a is less than 0 and b value is greater than 0. Let's consider a value to be 5 and b value to be minus 2. Then your LHS is equals to root a into root b. This is equals to root 5 into root of minus 2. Now we know that root of minus 2 can be written as root 2i, because I is equals to root of minus 4. So this can be written as root of 5 into root of 2 into I. is equals to root of 10 into I. So RHS is equals to root of A into B, which is 5 into minus 2. This is equals to root of minus 10, which is equals to root of 10 into I. So the condition is valid when both are when B is negative and A is positive. Similarly, we can prove that second, this value is also true. Let's consider A to be minus 2 and B to be 5. So it's the same values that we are considering. We're just swapping the variables. Here also you'll get the same result, that your LHS equals to RHS. Now your equation was root of A into root of B is equals to root of AB. What happens when both A and B are negative? If A is less than 0 and B is less than 0, let's consider examples. A is equals to minus 3 and B is equals to minus 2. In this scenario, your root of A into root B becomes equal to root of minus 3 into root of minus 2. Now this is equals to root 3I multiplied by root 2 into I. This is equals to root 3 into root 2 into I square, which is equals to root 6 into minus 1, which is minus root 6. Root of AB can be written as root of minus 3 into minus 2. This is equals to root of 6. Now, if you can observe, this is a positive value and this is a negative value. So from here, we can see that root A into root B is not equals to root of AB. This condition, this equation, root A into root B is equals to root of AB, is valid only for 3 conditions: when both A and B are positive real numbers, or either of the two A and B is a negative number. Next, what happens if either of the two numbers is 0? A is equals to 0 and B is any non-negative number. Or A is equals to any non-negative number and B is equals to 0, or both A and B are zeros. In these scenarios, your LHS will be equals to 0 and your RHS will also be equals to 0. Hence the equation holds true. There are some polynomial expressions, there are some polynomial formulas based on polynomials valid for real numbers, which are also valid for complex numbers. Let's see some of these formulas. Let's consider two complex numbers, Z1 and Z2. If you take Z1 and Z2 whole square, this will be equal to Z1 square plus 2 times Z1 Z2 plus Z2 square. Z1 minus Z2 whole square. This will be equal to Z1 square minus 2 Z1 Z2 plus Z2 square. Z1 plus Z2 whole cube will be equal to Z1 cube plus 3Z1 Z2 square plus 3Z1 square Z2 plus Z2 cube. Z1 minus Z2 whole cube will be equal to Z1 cube minus 3 Z1 square Z2 plus 3 Z1 Z2 square minus Z2 cube. Z1 square minus Z2 square will be equal to Z1 plus Z2 into Z1 minus Z2 and so forth. These are some common expressions, common polynomial equations or relations that we have proven equivalent to complex numbers. Let's study the next topic, modulus and we've already seen inverse. So modulus and conjugate of complex numbers. Modulus. So modulus and conjugate of complex numbers. If z is a complex number, a plus ib, then modulus of z is represented like this. Whose value is equals to square root of real part square plus imaginary part square. Conjugate, on the other hand, is represented by z bar. This value is equals to real part as it is and negative of the imaginary part. Now we know that z inverse, we have seen the formula for z inverse in the previous class. Z inverse is 1 upon z, which is equals to a minus ib upon a square plus b square. The denominator can, so if we substitute these values, a minus ib is conjugate of z, which is z bar upon a square plus b square. This can be written as mod of z whole square is equals to a square plus b square, taking squaring both sides. So this value can be substituted in the denominator part, which is mod of z whole square. Taking this value on the left hand side, we can see that z conjugate is equals to z inverse multiplied by mod of z or modulus of z whole square. We'll continue about complex numbers in the next class. Thank you.